This is the #1 AI model in the world right now. If you look at the top models, they're all proprietary. You can access them through APIs, but you can't download them and you can't run them locally. In most cases, you're also sending your private data to companies like OpenAI, Anthropic, and Google. So let's filter it down and pick the best model you can actually run on your own machine. The first question, can you run this model at all? If it's API only, it's out. So we start our search by narrowing it down to models with open weights. These are the models you can download and run locally yourself. Right now, most open weight models are ranked a bit further down the overall leaderboard. So right away, you're sacrificing some capability in exchange for control, privacy, and local performance. Open weights means that you can run the model locally, but it doesn't always mean that you could do whatever you want with it. For personal projects, you're almost always fine, but if you're running a business, you'll want to check the license for any commercial restrictions. Now that we're only looking at open weight models, the next question, what size model can you actually run? Model size controls everything. If it's too big, it won't fit, or it'll run too slow. Too small, it's faster, but maybe not capable enough. So you're balancing 3 things. It has to be small enough to fit in memory, big enough to handle your task, and fast enough to feel responsive. And this is where distillation can be useful. Some models are trained to imitate larger ones. Distilled models, even though they have the same parent model, they're different models altogether. But we can still find the smallest model that meets our needs within the same model family. Kind of like a watered-down version that's often good enough. Once you've picked a model, you need to make it run well. So our next question, how much quality are you willing to trade for speed? Quantized models are compressed. You use less memory, sacrificing quality for faster inference. So now you're not choosing a different model altogether, you're choosing a version of the same model by preserving or degrading what's already there. By default, most local setups run models in a compressed 4-bit format to keep them fast and usable. But you can pick the highest quality version that still runs fast enough. Since I'll be running everything locally on an Apple Mac Mini, let's look for models around the 7 billion parameter range. That'll strike a good balance between performance and what consumer hardware can actually handle. Here are some of the models that look promising based on the criteria we've identified. First, Llama 3.1 from Meta. This is a well-rounded 8B model. That's a good general baseline. Next, Qwen 2.5 from Alibaba. This is a highly capable 7B model that's especially strong at reasoning and coding. And Gemma 3 from Google. This is a smaller 4B model, but surprisingly capable for its size. There are newer models like Gemma 4 that have been specifically optimized for edge and multimodal, but it's not an even comparison with the other models that we're looking at here. Now let's talk setup. I'm using Ollama, a free and open source framework to pull and run the models from the command line so everything runs locally on device. I'm already SSH'd into my Mac Mini, so let's first install Ollama and download our first model and run it. Let's include the verbose tag so that we'll be able to see our performance metrics. All right, let's test the models with a few different prompts. First, a logic puzzle. This requires step-by-step reasoning and planning. So you have a 3-liter jug and a 5-liter jug. How do you measure exactly 4 liters? Let's run them side by side. So we have the same problem, the same setup, it's just pure reasoning. Llama is really confident, but actually doesn't make much sense. So I don't think it got it this time. Qwen and Gemma are giving similar answers. They're tracking the state across each step. And I would say both of them got it correct. And you can see the performance metrics here, like duration in seconds and eval rate in tokens per second. But I'll tally it at the end so we can see what it looks like across models. Next, let's ask the models to explain something. We're looking for a clean and structured response that's easy to understand. Explain what quantization is in machine learning like I'm a beginner in under 5 seconds. Let's run them side by side. So they all answered this one correctly, looks like, and explained the core idea of quantization, but they didn't do equally well. So if you read it, Llama is correct, but it's a bit generic. Qwen probably has the most technically accurate answer. And I like Gemma's the best here for this specific prompt. It was really clear, simple for a beginner, and easy to follow. So they all passed this test, but there's some additional signal as to what you're really looking for here. For our last test, a real-world question. This might require a little bit of prioritization and world knowledge, and might even require a few follow-up questions. You have a Mac Mini with 16 gigs of RAM. What size model should you use and why? So let's run them. Okay, I sped this up. It actually took a bit longer than I planned, but I'm glad we did it. So this is where we actually see the biggest difference between the different models. Gemma was the only model to get this one right away and answer the question in one shot. Qwen eventually got there, but I had to follow up with a few additional prompts. And Llama, this one isn't Llama's fault. So its training cutoff date is in, it looks like late 2023. So it hasn't even seen some of these newer models that I included in one of the follow-up prompts. But even with that, it didn't adapt. Instead of reasoning through the constraints, it gave a really generic answer. And I could have added more and more detailed prompts, but it still missed the core of the problem. It didn't really get it. All of these models are running locally, so their world knowledge is limited to their training cutoff. And unless you explicitly add tools like search or retrieval, your model won't have access to live or any external data. So if you need something like the latest news, it just won't have access to that. Now on to what actually matters. First, speed. Gemma was the fastest with the highest tokens per second. Qwen and Llama were slower, but still very usable. No one cares about speed if the answer isn't right. So did the models actually solve the problems? Llama, no, not consistently. Qwen, consistently, yes. Gemma, also consistently, yes. Here, accuracy is table stakes. If it's not correct, nothing else matters. And lastly, how much work did it take to get a useful answer? Llama took a bunch of tries and never quite got there. Qwen, also multiple tries, but much stronger reasoning. Gemma's our clear winner here. So the fastest model isn't just the one that responds first, but the first one to give you something usable with the least amount of time and effort. For our 3 basic prompts, Gemma appeared to be the strongest. But it's not about finding any single best model in the entire world, or even the single best model in this video. It really depends on what you're trying to do. Maybe it's home automation, maybe it's coding, or even creative writing. But you want something private that works offline. This is an easy way to try out different models and figure out which one works the best with your constraints. These aren't the newest models, but they're some of the best ones that you can actually run locally today. You can think of the leaderboard like Formula One racing cars. Each winning model is surrounded by an entire ecosystem of underlying data. Pre-training, mid-training, post-training, and algorithm decisions that result in a family of models. What you run locally? It's a tuned-down street version of that F1 winner. So you can find the best descendant of the top models that fits your machine and works best for your specific use case. This is a great place to start. Thanks for watching, and I'll see you in the next one.